Welcome to the Planet of Maths channel. In this episode, we will talk about calculating absolute value, and this will already be a third, slightly higher level, because we will want to solve examples like these here. But to move on to such examples, we need to recall two more basic things. Namely, if we have an example like this one here, it's supposedly the case that if we have a square and a root, we can reduce it. The square root and square eliminate each other. I rewrite what's underneath, but here, unfortunately, I have to enclose it in an absolute value. That's how it is. These roots supposedly cancel with the squares, but you have to remember that the result must be a positive result, and that absolute value guarantees it. There is actually such a formula for the square root of x squared, and that's it. The absolute value of x. So if we have a second example like this, the square root will also cancel out with the square, and what remains in absolute value will be 2 minus the square root of 5. Further on, if we want to remove the absolute value, we must know whether this expression within the absolute value is positive or negative. We need to know whether the square root of 5 is greater or smaller than 2. And this assures us of the following. It is enough to square them. If I square the square root of 5, I get the number 5, and if I square 2, I get the number 4. The square of this number is greater than the square of that number, which means that this number is greater than that number. Here is a lot, here is less. So if I have such a subtraction, a large number minus a small number, the result of this operation is positive. And since the result is positive, I will write this expression from inside the absolute value in parentheses. Since it is positive, I won't change anything here. So I can actually write it this way. This bracket here was irrelevant. It will be different here. This time we have 2 is a smaller number, which we have already established. The square root of 5 is a larger number, so when I subtract the smaller number minus the larger number, I will get a negative result. Inside this absolute value, I get a negative result, so I can drop the absolute value. What I had inside here, I write in parentheses, but I must put a minus in front of the parentheses. These are the properties of absolute value. If we have a negative number here, the result will be the same as what was here, but with a minus in front. And after removing these parentheses, I get this result. The second thing that needs to be reviewed here is how to calculate examples like this one. This is a special product formula, specifically the formula for the square of a sum. And here we proceed as follows. According to the formula, we first need to square a. So we square this 7, which is 49. Then we also bring this sign here, and then it is 2ab. That means we need to multiply a and b 7 times the square root of 2, which is 7 square roots of 2. But this 2 says that we have to double it. From this, we get 14 square roots of 2. In the formula, there is still b squared, which is the square root of 2 raised to the power of 2. From this, we get the number 2. And I can still reduce 49 and 2. I'll get 51 from that. And these 14 square roots of 2 won't change at all. Another example is this one. Here we also have a special product formula. This will now be the formula for the square of a difference, because here we have subtraction. But it works the same way. A squared, which means I have to square this entire expression. 2 squared is 4. The square root of 2 squared is 2. I have to multiply it by itself, which will be 8. Then in the formula, there is 2ab, which means I have to multiply a by b. This times this, I have to multiply. 2 times the square root of 2 times 3 is 6 times the square root of 2. This is ab, and I have to double it. I will get 12 square roots of 2 from this. And finally, there is plus 3 squared. 3 squared is 9. I can still reduce this 8 and 9. It is 17 minus 12 square roots of 2. And now the results of these examples. I wanted us to look at where this 51 came from. I'm not very interested in that. It was from the beginning and the end. I'm more interested in these roots, these 14 roots of 2. So what is it? It's what we had here, which is ab, but multiplied by 2. It's doubled ab, and here this piece with radicals, 12 square roots of 2 is also what I wrote here. It was a times b, but doubled. We will need this soon in our examples that we are aiming for. We already have this example a. For such an example, to solve it, we need to take what we have here under the absolute value and first examine it. I mentioned that we look at this fragment with roots. Here I have 6 square roots of 2, but that is 2a times b. And I would like to know what a times b is, so without the 2. So I have to divide it by 2. This will result in 3 square roots of 5. This is a times b, and now what could a and b be? The first possibility for a times b to equal this expression could be that a equals 3, and b equals the square root of 5. From such multiplication, I will get this result. But this is not the only possibility, as there is also the option that a could be equal to 1, and b could be equal to 3 times the square root of 5. These are the only 2 possibilities. To get such a result from multiplying a by b, it has to be one way or the other. So we need to check which of these options will fit us. There is a, there is b. In parentheses, we will write a, we will write b squared, and now the sign here depends on the sign we have before these roots. In this case, it will be a minus because there is a minus here. So for us, it will be 3 minus the square root of 5 squared. This is the first operation that we will check. The second operation that we will check, meaning a minus b squared, is 1 minus 3 square roots of 5 squared. From one of these 2 operations, we should get such a result. We check the first operation. Here it's 3. 3 squared is 9. I take this sign from here, which is minus. Then I multiply this by that, which gives me 3 times the square root of 5. And I need to double it. So that makes 6 times the square root of 5. And then add the square root of 5 raised to the power of 2. That is 5. I reduce 9 and 5 and get 14, minus 6 square roots of 5. From this, I got exactly what is here. Let's check the second option, because maybe someone doesn't believe me, so let's see what happens now. When I raise 1 to the square, it will be 1. 1 times 3 square roots of 5 is 3 square roots of 5. And I double it. That gives me 6 square roots of 5. This part repeats for me here, but the rest won't repeat because now I'll square 3, which is 9. I multiply it by the square root of 5 squared, which is 5. And together, I get 45. So in total, after reducing 1 and 45, I will get that this will be 46 minus 6 times the square root of 5. And we see that this option does not fit. This option does fit. Here it is wrong. Here it is correct. So we calculated that such an operation, that is, the one we were interested in, is the same as this. Such a bracket squared. So 3 minus the square root of 5 raised to the power of 2. From such an operation, this is the result. Now that I know this, I'll go back to this example up here. Under the square root, instead of what I had, I'll write something like this in parentheses, which I calculated. And I have a square root. I have a square. So I eliminate the square root and the square, but I write the result in absolute value. And now I need to determine which number is larger, 3 or the square root of 5. I square the 3, which is 9. I square the square root of 5, which is 5. The squares show the larger square here. This means that the number 3 is larger, so I have a large number minus a small number. From such subtraction, I'll get a positive result, which means I can write what's inside the absolute value without any changes. This is the result for example A. Example B looks like this. So we do it by taking what was under the absolute value, which is this operation, and we will calculate it here. We look at this fragment with roots. This is otherwise 2 times AB. This means that A times B must be equal to that divided by 2, which means it must equal the square root of 3. When I multiply A times B, I should get that much. And what options will there be here? How can you only see one number here? It is possible that A will be equal to 1, and B will be equal to the square root of 3. And actually, there's no other possibility in this case. Multiplying 1 by such a root gives me that, so the doubled product of A times B will be 2 times the square root of 3. That must fit? We check then. We take A in brackets, which is 1. There was a minus sign before this term, so I put minus here and give B, which is the square root of 3. Now I'll just check if it really fits, but it must fit. I square this one from the formula. 1 squared is 1. Then I have to multiply this by that, which is the square root of 3. 1 times the square root of 3 is the square root of 3, but I double it, and it comes out to be 2 times the square root of 3. With this sign, meaning with the minus. And then there is also a plus. The square root of 3 squared is 3. 1 with 3 gives 4, I rewrite the rest. And that suits me. That's exactly it. That means I can replace this operation with such a bracket squared. This is the same. Returning to this main example, instead of this operation which I had here under the root, I write such a bracket raised to the power of 2. The square root and square cancel out, but I need to enclose the result in absolute value. To remove this absolute value, I square it. I square 1, which is 1. I square the square root of 3, which is 3. And I see that this square is smaller than that square. This means that this number is small and the other number is large. If I subtract a small number minus a large number, the result of such an operation is negative, which means I can then drop the absolute value. But what I got here, I must enclose in parentheses and put a minus sign in front. Now I drop the bracket, the minus changes the signs, so it becomes negative 1 plus the square root of 3. And this is the result for example B. Example C looks like this. In that case, we take what is under the square root, this expression. Here, where these square roots are, it is 2a times b. And I want to know how much a times b will be. A times b will be half of this. I divide it by 2, which gives me 4 square roots of 7. What are the options here? The first possible option for a times b to equal this is that a equals 1 and b equals 4 times the square root of 7. From such a multiplication, I get this result. That is the first option. The second option will be that a equals 2, and then b would have to equal 2 times the square root of 7. From such multiplication, I would also get this result. There's a third option. A could equal 4. B will equal the square root of 7, and from this operation, I will also get that result. So here I have 3 possibilities, one of which will be correct. We'll calculate and look for the right one. Here, we take 1 into the parenthesis, we take 4 square roots of 7, which are A and B. Here it will definitely be squared. The sign we use is the one in front of those square roots of 8. Here is a minus sign. And so I calculate. 1 raised to the square is 1, the sign is definitely from here. Then there's the doubled product, so I do the product of this times that, which is 4 square roots of 7, but I double it, and it becomes 8 square roots of 7. And finally, there is b squared, so I have to square it. This squared is 4 squared, which is 16, and the square root of 7 squared is 7. I multiply 16 by 7, which gives me 112. When I add 1 and 112, I get 113 minus 8 times the square root of 7. And it's clear that this doesn't fit. The result didn't come out as it should have. I wanted it to be this much. So the first option is not good. I check the second option. In the parentheses, I put A, I put minus B. And I square it. 2 squared is 4. Then it's minus, and it is the doubled product, so I multiply this times this. And I get 4 square roots of 7 again, and just like up here, I double it, resulting in 8 square roots of 7. And finally, I need to calculate what the square of this will be. So I square 2 to get 4. The square of the square root of 7 is 7. So from this, I get 28. And here I can already see that this is not going to be good, because 4 and 28 gives me 32, and I would like to have 23 here. So this is not a good option either, so the last one must be right. Here it will be 4 minus the square root of 7, which is a minus b and squared. Raising 4 to the square gives 16. I multiply this by that, which are 4 square roots of 7, but I have to double it so it will be 8 square roots of 7. And finally, the square root of 7 squared is 7. I reduce 16 and 7, which together is 23. So I have what I wanted. I ended up with exactly what was here. And that's a good option, the last one. It means that such an expression, such a one, can be replaced with such a bracket squared. Once I know this, I move on to the actual example. I rewrite the root, but under the root instead of this expression, I put that. And now the square root and the square cancel each other out. But what I had under the square root, I write inside the absolute value, which is 4 minus the square root of 7. Will it be positive or will it be negative? It depends on whether 4 is greater or the square root of 7 is greater. 4 squared is 16, and the square root of 7 squared is 7. So here this is more, this is the greater number, this is the lesser number. That means from such subtraction, I will get a positive result. So I can drop the absolute value and nothing will change. I could put parentheses here, but when I have a positive number, the parentheses are not needed at all. They change nothing here. And that's all for this video. Thank you for watching, and I invite you to tune in for the next episodes on the Planet of Mass channel.